Welcome to our video on Chandrayaan Mission 3, India's third lunar exploration mission. In this video, we will explore the significance of this mission and how it differs from other moon missions carried out by countries such as the USA, Russia, Japan, and China. Join us as we delve into the details of this exciting mission and learn about its importance in advancing our understanding of the moon. Stay tuned. The Indian Space Research Organization, ISRO, is a space agency that has been making strides in space exploration. One of its most ambitious projects is the Chandrayaan program, which aims to explore the moon. Chandrayaan Mission 3 is the third lunar exploration mission under this program. It is a follow-up to Chandrayaan-3 of July 2019, which aimed to land a rover on the lunar South Pole. The subsequent failure of the Vikram lander led to the pursuit of another mission to demonstrate the landing capabilities needed for the Lunar Polar Exploration Mission proposed in partnership with Japan for 2024. So why is this mission so important? For one, it represents India's continued efforts to explore and understand our closest celestial neighbor. The mission aims to demonstrate crucial capabilities to soft land on the lunar surface safely that the earlier mission could not achieve. This will pave the way for future interplanetary missions by ISRO. But how does Chandrayaan Mission 3 differ from other moon missions carried out by countries such as the USA, Russia, Japan, and China? Each country has its own unique approach to lunar exploration. For example, the USA's Apollo program focused on crewed missions to the moon, while the Soviet Union conducted uncrewed missions that deployed rovers and returned samples to Earth. Japan's Lunar Exploration Program aimed to elucidate the origin and evolution of the moon and utilize it in the future. China's Lunar Exploration Program incorporates lunar orbiters, landers, rovers, and sample return spacecraft. Chandrayaan Mission 3 stands out as a demonstration of India's technological capabilities and its commitment to advancing our understanding of the moon. It is an exciting time for space exploration, and we look forward to seeing what new discoveries and achievements this mission will bring. NASA has been exploring the moon since the 1960s with its Apollo program. The program focused on crewed missions to the moon and was successful in landing astronauts on the lunar surface. In addition to crewed missions, NASA also sent several uncrewed missions to explore the moon. These missions included orbiters, landers, and rovers that gathered valuable information about the lunar environment and surface features. NASA's current Lunar Exploration Program aims to return humans to the moon by 2024 with its Artemis program. The program includes plans for a sustainable human presence on the moon, as well as exploration of its resources and scientific potential. NASA is also working with international partners to develop a lunar gateway, a small spaceship in orbit around the moon that will provide access to more of the lunar surface than ever before. The Artemis program is named after the goddess of the moon and twin sister of Apollo. Under Artemis, NASA will send new science instruments and technology demonstrations to study the moon, accelerate plans to send astronauts to the moon by 2024, and establish sustainable lunar exploration by 2028. The main parts of the program are the Space Launch System, SLS, the Orion spacecraft, the Lunar Gateway space station, and the commercial human landing systems. Now let's take a look at Roscosmos's Lunar Exploration Program. Roscosmos is Russia's space agency and has a long history of exploring the moon. During the Soviet era, Russia conducted several uncrewed missions that deployed rovers and returned samples to Earth. These missions included the Lunar Program, which sent a series of spacecraft to explore the moon between 1959 and 1976. More recently, Roscosmos has announced plans for its Lunar Globe program, which aims to create a fully robotic lunar base. The program includes several missions, starting with the Lunar 25 lander, which is scheduled to launch in August 2023 and land near the moon's south pole. The Lunar Globe program also includes plans for orbiters, landers, and rovers to explore the lunar surface and gather scientific data. When completed, the Lunar Globe program will continue with crewed lunar missions, starting with a crewed orbiter spacecraft called Orel. Roscosmos is developing the Orel spacecraft as a next-generation crewed spacecraft to take the place of the Soyuz spacecraft currently in use. The Orel spacecraft is designed to support crewed missions to low Earth orbit, the Moon and beyond. Japan's Lunar Exploration Program is another interesting example. The Japan Aerospace Exploration Agency, JAXA, is in charge of the country's Lunar Exploration Program, which aims to understand the Moon's origin, evolution, and potential future uses. JAXA has sent several successful missions to explore the Moon, including its Kaguya orbiter, which gathered detailed information about the lunar surface and environment. The Kaguya orbiter, also known as Selene, Selenological and Engineering Explorer, was launched in 2007 and conducted a detailed survey of the Moon's surface, topography, mineralogy, and gravity field. The mission also included two smaller satellites, Okina and Una, which were used to study the Moon's gravitational field. JAXA is also working on a Lunar Polar Exploration Mission in partnership with ISRO that aims to send a rover and lander to explore the South Pole region of the Moon no earlier than 2026. The mission will focus on exploring the potential for water ice in the lunar South Pole region, which could be used as a resource for future human exploration of the Moon. China's Lunar Exploration Program is also worth mentioning. China's Lunar Exploration Program is run by the CNSA, China National Space Administration, and incorporates lunar orbiters, landers, rovers, and sample return spacecraft. China has had several successful missions to explore the Moon, including its Chang'e series of spacecraft. The Chang'e program is named after the Chinese goddess of the Moon and aims to explore the lunar surface and environment. The program includes several missions, starting with the Chang'e-1 orbiter, which was launched in 2007. Subsequent missions have included orbiters, landers, and rovers that have gathered valuable information about the Moon. Most recently, China's Chang'e-5 mission successfully returned samples from the Moon in December 2020. The mission included a lander that collected samples from the lunar surface and a return vehicle that brought the samples back to Earth. This was the first time in over 40 years that samples have been returned from the Moon. Coming to India's Chandrayaan-3, the Chandrayaan-3 mission cost around Rs. 615 crore or $75 million, making it one of the most cost-effective Moon missions ever undertaken. Getting to lunar orbit took so long for Chandrayaan-3 because of the approximately 384,400 kilometers it had to travel from Earth. In order to get the probe to the Moon in under a month, the Indians employed a considerably less powerful rocket than the American Saturn V and had it make 5 or 6 elliptical orbits of the Earth to acquire speed. A soft landing on the Moon for the spacecraft is scheduled for August 23rd or 24, 2023. The 6-wheeled rover will be released upon landing, at which point it will explore the lunar surface's rocks and craters and send back vital data and photographs to Earth for further study. The rover may operate for a total of 14 Earth days or 1 lunar day. The Chandrayaan-3 rover carries several scientific instruments designed to deepen our understanding of the Moon. These instruments include Chandra's Surface Thermophysical Experiment, CHASTE. This instrument will measure the thermal conductivity and temperature of the lunar surface. Instrument for Lunar Seismic Activity, ILSA. This instrument will measure the seismicity around the landing site. Langmuir Probe, LP. This instrument will estimate the plasma density and its variations. These instruments will help scientists gather valuable data about the lunar environment and surface features and further our understanding of the Moon. Thank you for watching this video. We hope you have enjoyed learning about this important mission and its significance in the field of lunar exploration. Please don't forget to like, share, and subscribe to our channel for more interesting content. Thank you for joining us, and we hope to see you again in our next video.